Okay, hello everyone. My name is Mahesa Putranata, NPM 20064880045, from the Electrical Engineering Department at Universitas Indonesia. In this video, I would like to present my experience internship at PT Twink for about 2 months, starting from the background, development stages, and the activity that I did in my internship. So, begin with the background. Let me start the explanation by introducing the company background. So, the company that I did in the internship is in Petit Wing, which was established in 1960s. Petit Wing Indonesia began as a family trading business with a focus on supplying products to PT PLN, or we can say Persero, the state-owned national electricity company in Indonesia. And over time, the company experienced consistent growth and emerged as a prominent player in the Indonesia electrical utilities industry. So this early foundation allowed PT Twing Indonesia to establish a strong foothold and build expertise in serving the needs of the power sector. Furthermore, in its pursuit of growth and innovation, PT Twing Indonesia sought a strategic partnership to enhance its product offering. The company entered into a license agreement with Siemens Energy AG, or the Germany product, renowned global player in the energy sector. So this kind of collaboration enabled the patent Wing Indonesia to manufacture both air insulated switchgear, or we can say AIS, and gas insulated switchgear, or we can say as the GIS, locally. So by producing these essential electrical equipment within its own facilities, Patent Wing Indonesia strengthens the domestic industry, increase local content, and addresses the growing demand for electricity from PT PLN, or let's say the Persero. Okay, today PT Twin Indonesia remains committed to delivering reliable electrical solutions and contributing to the development of the Indonesia power sector with a strong presence, extensive project experience, and focus on innovation. The company continues to serve the evolving needs of its client. One of the focus electrical component sector on Petit Wing is the circuit breaker. There are many models that have been produced by Petit Wing, but one of the models that I studied on my internship is the 3AP1FG 170 kilovolt model. Okay, so before I further explain about the 3AP1FG 170K model, one of the model of the circuit breaker, here I would like to briefly explain about the basic concept of a circuit breaker itself. So what exactly is a circuit breaker? Simply put, a circuit breaker is a safety device designed to protect electrical circuits from overloads and short circuits. So let's imagine an electrical circuit as a pathway to allow electrical to flow. Now, sometimes due to the various reasons such as malfunctioning appliance of a surge in current, the flow of the electrical can become too high, potentially causing damage or even fires. This is where the circuit breaker comes into play. It acts as a safeguard, monitoring the flow of the current within the circuit. When the circuit exceeds to a safe limit, the circuit breaker automatically trips or switches off, interrupting the electrical flow. Circuit breakers are often installed in a centralized location, like a circuit breaker panel, where multiple circuits are controlled. Once the circuit breaker trips, it needs to be manually reset. This allows the fault or issue to be resolved before restoring the electrical flow. It's important to note that the circuit breakers come with a different trip settings to accommodate variable levels of current. This allows them to protect different types of electrical circuits, from small household circuits to a larger industrial circuits or ones. Now let's delve into a specific model, which the model that I studied in this internship, which the 3AP1 AP1 over 2 circuit breaker. So the 3AP1 2 circuit breaker is a specialized type of high voltage switchgear designed to safeguard electrical component and system from damage caused by the overcurrent or other fault condition, for instance. What sets the 3AP12 circuit breaker apart is its gas insulated design. It utilized sulfur hexafluoride, or we can say the SF6, as the insulating and arc cohesing medium. So the SF6 here is ex- is an excellent electrical insulator. Basically, it's a new type of insulator that has a function to allowing for compact and efficient construction. So inside the 3AP12 circuit breaker, the SF6 gas forms a scaled enclosure around the contacts, providing insulation and extinguishing any electric arcs that may occur during the fault event. Now, let's explore the control system of the 3AP12 circuit breaker, responsible for monitoring the electrical parameters in the circuit and ensuring the breaker's optimal performance. The control system can be electromechanical, where trip coils are energized by the control system. It allows to detect abnormal or dangerous conditions and open the breaker's contacts. Alternatively, alternatively, the control system can be microprocessor based, utilizing electronic circuits and software to implement advanced control functions. This enhances safety and reliability by responding swiftly the conditions like overcurrent and protecting both the electrical equipment and overall system. By monitoring the electrical parameters and swiftly reacting to faults, the control system in the 3AP12 circuit breakers ensures the safety operation of the electrical system or will be preventing the damage and potential hazards. To sum up, the 3AP12 circuit breaker is a specialized gas insulated high voltage switchgear that use the insulated type of the SF6 gas as it is insulating the arc cohesing medium. Equipped with either an electromechanical or microprocessor based control system, it provides reliable protection against faults, promoting the safety and efficiency of vehicle equipment and systems. Now, in my internship timeline, it is divided into several stages, which are conceptualization and planning, requirements analysis regarding the budget and suppliers, and design the circuit mapping. Okay, so starting with the first stage, which are the conceptualization and planning. During the initial phase, I immersed myself in the study of circuit breaker anatomy. I took time to explore various types of circuit breakers, examining their physical structure and functional aspects. So I carefully observed the existing circuit breakers, gaining valuable insights into their internal component and how they work together to provide electrical protection. I analyzed their mechanism from contactors, relays, fuses, switches, indicators to terminals, comprehensive understanding how they integrate into the circuit breaker system. Now, to ensure a comprehensive understanding, I consulted technical manuals, circuit diagrams, and online resources. These resources provide me with a vital information about the purpose and operation of the each components. As I progressed, I compiled a detailed list of essential components required for building a circuit breaker. The comprehensive inventory ensured that I had all the necessary parts ready to assembly stage. Simultaneously, I dedicated time to measure the cables that would be involved in the circuit breaker. Accurate measurements were very crucial to minimizing the budget and also to ensure proper fit and optimal performance. I meticulously measured the length and the specification of each cable, noting them down for the future reference. By investing time in conceptualizing and planning, I laid a solid foundation for this successful construction of the circuit breaker. The meticulous approach allowed me to understand the the anatomy and compile the comprehensive list of the each components. So the output from the stages here is here I already able to identify what are the components that needs to build a circuit breaker. So starting from the first component,
which here is the resistor. Here the resistor labeled as 3B2030080007 in specification 560 ohm. Basically, it has the same function as the odd resistor, which has a function to handle power and is designed to convert the energy into heat energy. Moving on to the next component. So which here there are solenoid, AC motor, and there's another resistor again. So here the solenoid is designated as an opening solenoid in a control system for a circuit breaker. Typically functions to open the circuit breaker when the solenoid is energized. Basically, the solenoid is an electromechanical device that converts electrical energy into mechanical motion, which basically solenoid works when the solenoid is energized with the DC voltage. In here is in 110 volt. It generates the magnetic field and pulls the rod, or we can say a plunger, which mechanically opens the circuit breaker itself. Next, there is the AC motor here, which here the AC motor assembly designated as a charging motor in the control system for a circuit breaker typically functions to charge the stored energy in the operating mechanism of the circuit breaker. So in some types of circuit breakers, the stored energy is used to trip or close the breaker contacts, and the charging motor is responsible for maintaining the stored energy level by continuously charging the mechanism. Next, moving on to the next component, which is starting from the lighting. Here, basically, the lighting it is labeled as the SHB C64111 E227 in a specification 220 until 240 volt, which has a power requirement of 18 watt. It's a type of original light bulb. It is likely used as a part of control system in a circuit breaker. So the specific function of this light bulb in the control system is typically used to indicate the status of the circuit breaker and provide visibility for maintenance and troubleshooting. Moving on to the next component, which there is the thermostat. Thermostat such as the here we use the 3L23 2000001 0 ODES, which the THE11, which this is a device that is used to control the temperature condition within the circuit breaker control system. So the thermostat monitors the temperature of the system and activates or deactivates certain components to maintain the desired temperature range, which this helps to ensure that the circuit breaker and the other components within the system are operating within the safe temperature limits. Or we can say it helps to prevent damage or prolong the life of the equipment itself. Next, moving on again to the next component, which there are DCMCB and the ACMCB. Starting with the ACMCB, which the label of the factory from the ACMCB is the 5SY6 C102P and 5ST30110 3L53300011001 and NSHV C6 2020 in a specification of 10 ampere is a miniature circuit breaker or MCB which has a function will disconnect the connection at this zero volt point, put out the arc and safeguard the wiring from excessive current. So when the AC MCB disconnect in this situation, the the lamp, they already said before, inside the circuit breaker will illuminate in the bright red. And for the next component is the DCMCB, which DCMCB is a type of circuit breaker that is used to protect the circuit motor in a control system from the trouble of overcurrent and the short circuit conditions. So the specific model numbers that are product codes for different types of the DCMCBs, which are designed to protect the motor. So these DCMCB are used in the control circuit, yeah, in the control system of the circuit breaker itself that has an item designation as motor protection. Continue from the auxiliary contactor. So yeah, Basically, here as a function to add more context for controlling the operation of the circuit breaker, an auxiliary contactor is employed in the control circuit, which here we use the both Siemens auxiliary contactor, which has labeled of manufacturer 3 RH6140 1BF40 and 3RH2911 1GA04. In contrast, the to the 3RH2911 1GA04, it has a specification 1 pole for ample auxiliary conductor, and the 3RH6140 1BF40 is had a 3 pole and 40 ampere. So the breakers are 110 volt DC and have the parts number 958 10,000 and 950 So these contactors are utilized in the control system to provide the circuit breakers extra control over how it operates, including the ability to control when it trips and when it closes. Now moving on to the right side, here the function of the socket, such as the 3L7413000102, which in socket has a specification 230 volt and 16 ampere. In the control system of circuit breaker, it is to provide a connection point for the control circuit of the breaker itself. Next, there is the time relay. The function of the Weidmuller SHV C781015 WTR 110 volt DC, which time relay has a function in the control system for a circuit breaker would likely to be monitor and control the running time of the circuit breaker itself. So basically, this could control the amount of time that the circuit breaker is open or closed, and monitoring the total running time of the circuit breaker, and possibly even shutting down the circuit breaker if it has been running for an excessive amount of time. And moving on again to the below of the time relay, which consists of the key switch, button, and counter without reset, which here have a function to let the controller to interrupt the circuit breaker manually. Okay, going to the last part, which is the heater. Here, the heater, it used the label manufacturer 3B599 20102 has a specification 600 until 600 per 100 watt in the control system. Basically, this heater has a function to provide heating to the circuit breaker. So the heater is rated at 100 watt. Which means it's designed to provide a heat to the breaker to keep it within the specified temperature range. But in here, the heater is not really used.
Now, besides that, I also group all of the components into a form of table that is made in the Google Sheet. Other than that, I also group the cable length that is needed to make the circuit breaker in the form of the table, as the same as the component that needed to make the circuit breaker itself. Okay, so moving on to the next section is the requirements analysis regarding the budget and suppliers. During the sections, my primary responsibility was to list and budgeting the components that was required for constructing a circuit breaker. This involved conducting extensive research and utilizing of various e-commerce platforms such as the used is Tokopedia, Listrikita, and Tiga Pasa, which those stores are a local store, and to find the suitable suppliers for the components. Now, to begin the process, I create a table in a Google Sheet to list and organize the components. The table so the table allowed for easy tracking and reference of the components throughout the internship. Each component was assigned in a row in a table, and relevant information such as the component name, the description, the function, the quantity need, and the supplier details, and also the price, of course, and was included in the corresponding columns. Now, using the information gathered from my true study of circuit breakers, I identified the specific components required for the construction of the circuit breaker itself. So this include contactors, relays, fuses, switches, indicators, terminals, and other necessary parts. As I found suitable suppliers on the e-commerce platforms, I record their details in the supplier column of the table. And this ensured that I had a comprehensive record of the components and the corresponding suppliers for the future reference. In addition to listing the components, I also had to consider the budget for acquiring these components. I researched and compared prices from different suppliers, different stores to determine the most cost effective options without compromising on quality. By carefully analyzing the prices and considering factors like shipping costs, I estimated the budget required for acquiring the components. Throughout the internship, I regularly updated the table in Google Sheets as I discovered new components or suppliers and as the budgeting process evolved. This allowed for efficient tracking of the progress and assured that all the necessary information was readily available. Now, moving to the last section is the design circuit mapping. In this phase, I take on a responsibility of designing the circuit breaker by creating a comprehensive circuit diagram or schematic. This process requires carefully attention to detail and true understanding of the circuit breaker's requirements. First, I analyze the overall circuit breaker design and identify the specific connections and relationships between the various components. This involves studying the functional requirements and specification of each component and determining how they interact within the circuit breaker system. Next, I focus on optimizing the placement and layout of the component to ensure efficient operation and ease of maintenance. I consider factors such as space constraints, accessibility for future repairs or replacement, and heat dissipation to ensure proper functionality and longevity of the circuit breaker itself. Using specialized design software, which I use the draw.io, I create a detailed circuit diagram that accurately represents the construction of the circuit breaker. The circuit diagram serves as a visual guide, illustrating the interconnection between the component and the flow of the electric current throughout the system. The enhanced clarity and ease of understanding, I labeled each component and its corresponding connection within the circuit diagram. This helps to avoid confusion during the assembly process and provides a clear reference for future maintenance or troubleshooting. Throughout the design phase, I pay close attention to standards and best practice to ensure compliance with safety regulations and electrical codes. I verify that the circuit diagram aligns with the intended functionality of the circuit breaker and that it meets the desired performance criteria. By investing time and effort in creating comprehensive circuit diagram, I lay the groundwork for the successfully construction of the circuit breaker, and the diagram acts as the blueprint, which will guiding the assembly process and serving as a valuable reference for future modification or upgrades. Overall, the circuit mapping phase is the critical step that in the circuit breaker's development, which all stages that already explained before, enabling me to visualize and plan the structure of the circuit breaker system before proceeding with the physical construction. And that's all. Thank you for listening my presentation.